Okay, we're picking up with the second part of the notes. This is going to be part 2 of the video, and we're going to finish off the notes for the upcoming test. So picking up a system can work like an assembly line in which the output produced by one part of the system becomes an input that is used by another part of the system. The inputs and outputs of the system can include material, energy, and information. Okay, easy examples for this are food. Okay, we think about the order as being very, very important with these systems. We use food as an example. We can't just implant the food into our stomach. We have to start by getting the food into our mouth, chewing it up, breaking it down, and then letting it get into our stomachs where digestion can take place and nutrients can be absorbed by our body. So it's very, very important that we follow that same system or that same process. Each process has to be carried out in the same order each time, since all parties or all parts rely on the work of the previous part. And some of the parts of the system are going to include the input, which is going to be the raw material or the food in the example that I was just using. The output, or what's finished, or the waste from the process. When we're talking about eating, we're going to get nutrients, we're going to get energy from the food that we eat. We're also going to get some waste afterwards. What we can't break down inside of our bodies then becomes waste. The system process is the order of actions of the system, chewing followed by the chemical breakdown followed by the nutrient absorption. So that's going to be the process, and we can kind of break this down with a little diagram here showing we have the input, we have the system process, and then we have the output. Basic systems are simple, and they have an input, a process that triggers that, and then an output. Okay, there's no way to really control those processes. They're kind of going to happen on their own automatically. In an open loop system, there's no feedback, and it's an uncontrolled system. With an open loop system, there's no loop connecting the output to the input of the system. And this is opposite of a closed loop system, and with a closed loop system, it's self-contained, and the system often possesses a feedback mechanism that acts as a control device to keep changes within desired limits. So if we're going to take a quick look at that, if we talk about our food example, we talk about we can eat, our body will then digest the food, and then if we look at the output as nutrient absorption or lack of hunger, then feedback would be the sensation of being hungry or needing food. If that feedback is very, very strong, then it's time to eat, and we have to add more food to the system and get the process started. If that hunger is very, very low, then we don't have a strong urge to keep that system going, and we don't need to input any more food into the system. So we have a feedback that kind of will help us control how much we need to rely on that system or get that process going, and how much we need to input to get a certain level of output. So there is that level of control. So we call that level of control a feedback. Feedback is the result of the output of the system. It alters the earlier inputs into the system process. We're going to look at other cycles. A cycle is going to be a sequence of events that repeats itself. We're going to talk about examples of cycles. We'll start with the water cycle. Okay, for the water cycle, we have things like precipitation, evaporation, condensation, which will lead to the formation of clouds, rivers, runoffs, streams. There's other things, lakes, oceans. We have transpiration, where we have plants breathing out water vapor and getting water vapor back into the atmosphere. So this is a water cycle. Again, it's a predictable sequence of events that's going to happen over and over and over again and again and again until that process is never going to end. That's why we have these cycles on Earth. Okay, with this diagram we can kind of see the different ways that water can move around through the water cycle itself. So we get precipitation that can lead to melting from snow falling on top of mountains, and once the snow melts it's going to turn into a liquid. From there it's going to get into places like rivers, or it can even get into groundwater. Okay, if it gets into things like groundwater, then it would be able to go back into the ocean then, or a lake, and then once it goes back into like an ocean or a lake, it can then evaporate back into the atmosphere and it would start the process over. When we get water on the surface, it precipitates down, it gets into lakes and rivers, it could evaporate back up, it can be released into the atmosphere through transpiration, or it can kind of sink back down. So when we look at transpiration, that kind of starts us over again. There are other areas we can look at on here as this water kind of starts going back down. Okay, and you can see as we click around, there are the different things that allow us to move within the water cycle itself. Going back to the notes. Okay, next we can get into the carbon cycle, and we talk about carbon as it moves through the earth as a system, and it's going to change. Carbon's a building block for life, so it's a very, very important one that we're going to talk about. It changes from a solid to a gas, and that's what we're going to focus on, is carbon, how it changes from a solid to a gas. Okay, plants breathe in the carbon dioxide, the CO2, and as humans, we're going to exhale that CO2. We also talked about different ways that carbon can get into the atmosphere through carbon emissions of cars, burning fossil fuels, coal, and different things like that. And carbon being a greenhouse gas, it's very, very important that when we talk about carbon being a greenhouse gas, it absorbs a lot of energy from the sun. And because it absorbs that energy from the sun, when we have an increase of carbon dioxide in the atmosphere, we're going to see temperatures around the globe increase, and that's literally our definition of global warming. Because of the increased levels of CO2 in the atmosphere, we're going to see an increase in the temperatures on Earth. Organisms decay and they produce carbon, so tree branches fall and eventually they start to rot. That will produce some carbon. Carbon gets sequestered in different things, and then usually gets locked up for a while. We did a whole lab on that, and I'm going to do a separate video on the activity we did on carbon sequestration in trees versus cars. There's other things, forest fires and burnt toast. When we get the black soot from a campfire, that's literally the leftover solid carbon. A lot of that gets into the air and gets back as CO2 as that carbon mixes with oxygen. From there we go on to another cycle, the nitrogen cycle, and that's going to be the way that nitrogen is going to move from the air to the soil, and from the soil to the plants and animals, and back to the air again. So very similar to the way we looked at the carbon cycle as moving from a gas to a solid. We're going to kind of see something similar with the nitrogen cycle. 78% of the Earth's atmosphere is made up of nitrogen. The gas form is not usable for most living organisms, so we have to look at how we can change that nitrogen, and the way we're going to do that is through bacteria. These atmospheric nitrogen needs to be fixed. Oh, here it is. The nitrogen fixing bacteria is going to change the bacteria, or the gas nitrogen, into a solid form of nitrogen that's usable to living organisms. So when we look at that bacteria is going to change the nitrogen into a compound, and that's going to be helpful for plants to grow. And then through eating the plants, we're going to be able to get some of that nitrogen. So animals eat the plants and absorb that into their bodies. Okay, animals excrete, die, or decay and release that nitrogen back into the soil. In some cases, like fertilizer, and that's what we have here. Who likes to drink milk? When we talk about cows, and manure, which is necessary for helping plants grow. Through denitrification, bacteria in the soil release the nitrogen back into the atmosphere. So we have the bacteria that can take the nitrogen out of the air and into the soil, and then we have a different type of bacteria that can then take that bacteria and release it back into the atmosphere. And we look at a little diagram here of the nitrogen cycle and some of the different ways that nitrogen can move around from the atmosphere and into the ground. And we can look at then the different types of bacteria here and how the bacteria can then fix the nitrogen so it can get into the soil, and then it can be used in then plants once it's into the soil, and then animals can absorb it through the plants, and that process or that cycle will repeat itself over and over, just like all the other cycles that we see on the earth. The last cycle that we're going to look at here is the energy cycle. And then we're going to look at some different forms of energy, some geothermal energy. On the Earth, we look at geothermal energy as like volcanoes, geysers, earthquakes, the idea of plate tectonics and continental movement and drift. Some other things we can look at is solar energy, things like wind, because the wind that's on the Earth comes from the sun and the different temperatures that we get on the surface of the Earth, ocean currents and waves. We can get tidal energy as a result of that, where we're going to have the moon pulling on the Earth and the sun, affecting the ocean. And we're going to see, just a couple brief examples of how the energy can be a cycle on Earth. And we're going to go into more detail into a lot of these in different parts of the year. So that's going to bring us to the end of the notes for the first test. I also gave out a vocab sheet, and the vocab sheet is right here, containing some of the vocabulary words. And again, just looking at these vocab words as I kind of get it to a view we can see here on the screen. A lot of the words we've gone over in the PowerPoint, so these aren't new words. We used a lot of different examples throughout the PowerPoints. So again, these are the 10 vocab words, and they will definitely be part of the test as well. Again, if you have any questions, feel free to stop by in class, whether it's homeroom or after class, and I will help you out as best I can.